Hi there. Today we're going to talk about similar triangles and indirect measure. As we begin to talk about this, there's some things we just have to know. And these are just, I guess I call them facts. Corresponding angles of similar figures have the same measure. That means if you have two figures that are similar, their angles, the angles that are in the same position in those figures, will have the same measure. If three angles in one triangle have the same measure as three angles in another triangle, the triangles are similar. So that's a way to determine whether or not triangles are similar. The length of corresponding sides of similar triangles are proportional, meaning they aren't exactly the same, but if you would set them up in a proportion opposite each other, they would be proportional. Ratios formed by corresponding sides are proportional. In the sense of, if you said proportion, I guess they're not really equal, but when you multiply them, they are. If you set up the proportion, like if one side's 2 to 4 and the other one is 6 to 12, okay? If you multiply, cross-multiply those, they are going to be, the two numbers will be equal. And here's another good example, and I would definitely draw these and put them in your notes. If you have two triangles, and here's the measurements of the sides, okay, and you set them up to each other, 6 is to 3, as 8 is to 4, okay? Cross-multiply, 6 times 4 is 24, 8 times 3 is also 24. You prove it by showing that they are equal, that they are actually indeed a proportion. Okay, now this comes in handy when you have a missing side of a triangle and you know that the figures are similar. Okay, for instance, here you go. We have two triangles. We know that this angle and this angle are equal. This angle and this angle are equal. We can assume, because these two and these two are equal, that indeed, if we were to measure, that this third one would also be equal. Having said that, we know they're similar because all of their angles are the same. So then their sides will be proportional. So you can set up a ratio to find this missing side. I like to set the smaller on top, but it really doesn't make any difference how you set it up, as long as you do it correctly. Okay? So 6 is to 10, 6 is to 10, as these are the corresponding sides. 6 is to 10 as 3 is to A. 6 is to 10 as 3 is to A. Cross multiply, and you get 6A equals 3 times 10. 6A equals 30. Divide both sides by 6, and you get A equals 5. And that's really a great way to prove it and a great way to find that missing side. We use this whole idea to solve problems with indirect measure. I think we call those shadow problems because they often include the sun and a shadow. They're actually kind of fun once you get used to setting them up. Okay, fact is the sun casts a shadow. Yeah. When there are two objects that the sun is casting a shadow on at the same time, and that's important, it can't be at two different times, the lengths of the shadows are proportional. Okay? So, we separate the objects and their shadows into two similar triangles. And here you go. Okay? Here's a tree, here's a man. Height of the tree, height of the man. We've just made them into two similar triangles. 90 degrees, 90 degrees. This measure of this angle and this angle are similar because the tree is casting the shadow on both of them. So it stands to reason, of course, that this one and this one would also be similar. Okay? Now we're given some information. That's a good one. You really need to draw this into your notes. The height of the tree is called h. Okay? We assume the land is flat and level. and that the person in the tree are perpendicular, which means standing straight up and down at a 90-degree angle to the ground. So we set it up in a table, which is kind of nice. Okay, you have the man's height, the tree height. We don't know the height of the tree. That's our missing number. We know the shadow length of the man. We know the shadow length of the tree. So we end up with 6 over x equals 7 over 32. 192 equals 7x, divide, and you get about 27 feet. Of course, we're not going to be able to be absolutely exact with this. This is more of a close science, estimate science, but you'd be surprised how right you would actually be, or how close you would be. Okay, here's another one. If a tree casts a shadow that's 18 feet long, while a 6-foot pole casts a shadow that's 9 feet long, how tall is the tree? Should draw a picture, set up the proportion, and find the answer. So here we go. Here's our tree. Here's our 18-foot shadow, here to here. Here's our 6-foot pole, and it's 9-foot shadow. Okay, two triangles that are similar, both have right angle here. Because the sun is shining, this angle and this angle will be the same measure. Likewise, this angle and this angle will have the same measure, since we're setting them up. Set it up with the box. The height of the pole, the shadow of the pole. The height of the tree, the shadow of the tree. Set them up in a proportion. Okay, and you end up with 6 times 18 divided by 9, which is the way some of you like to do it. I would write it, I would write it as 6 over x equal 9 over 18. But when it comes right down to it, you're taking 6 times 18, which is 108. You're going to divide both sides by 9, and your answer is 12 feet. That wasn't too bad. I hope this was helpful. Hope it gave you some ideas on how to set these kind of problems up. If you have more questions, be sure to ask me in class. Have a great day.